A warm greeting to all watching this presentation. Today, I'm going to present my research work on the topic Design and Evaluation of Flurbiprofen Loaded Albumin Microsphere. So coming to the introduction, sustained release, prolonged release, depot release. So these are the various terms of drug delivery system that are designed to achieve a prolonged therapeutic effect by continuously releasing the medication over a long period of time after administration of a single dose of drug. So the main goal of sustained release dosage form is to reduce the frequency of dosing and to increase the effectiveness. So two pictures that I have given here, you can see that one is microsphere and you can see the release or diffusion of drug to the surroundings. Whereas the second one, you can see that the graphical comparison of conventional drug profile over controlled or sustained release dosage form. And you can see that the sustained release dosage form is maintaining a constant therapeutic concentration range over a period of time. So coming to the comparison of microsphere over microcapsule, you can see that microsphere is a metric system, whereas microcapsule is a reservoir system, by which in microspheres, the drug and polymer is dispersed over a volume, whereas in microcapsule, you can see that the drug is encapsulated by the polymer. And coming to where we are going to use this microsphere, and it is inflammation, especially chronic inflammation. So we know that what is inflammation, if there is any offending agent or there is an injury to our body will activates our immune system releasing inflammatory cells. So in which acute and chronic inflammation is the classification of inflammation, where which chronic inflammation where our body continues sending inflammatory cells even there is no outside danger and it has to be treated. So flurbiprofen is an effective NSAID used in the treatment of chronic inflammation, and the only problem with the flurbiprofen is that it causes a certain level of irritation in the gastrointestinal mucosal membrane, that is ulceration. So the main objective of this work is to prepare flurbiprofen microspheres by using solvent evaporation method and to study the effect of drug polymer concentration on drug release as well as the release mechanism of flurbiprofen from the microspheres. And these are the advantages to it helps to prolong the therapeutic effect, it helps to minimize the frequency of drug administration, it helps to improve the convenience of patient compliance, as well as it's reduce the adverse effect. So these are the plan of work, four plan of work, which is starting from pre-formulation studies, preparation of albumin microspheres, evaluation of microspheres, and last one is in vitro release studies of microsphere, that is dissolution studies. So this is the drug profile, and we know that flurbiprofen is an NSAID and it comes under propionic acid derivative, which is a non-selective COX inhibitor. That is, COX means it's an enzyme which helps in the conversion of arachidonic acid into various inflammatory mediators. And the chemical formula of flurbiprofen is C15H13FO2 and molecular weight having 244. And regarding the solubility, it is practically insoluble in water, whereas it's soluble in organic solvents like ether and alcohol. It having a half-life of 2 to 2.5 hours, and it comes under a therapeutic category, anti-inflammatory and analgesic. So talking about the formulation composition of flurbiprofen albumin microsphere, I'm making 3 batches of a microsphere, that is FP1 flurbiprofen 1, FP2 and FP3, and the only difference is in the drug polymer ratio. I'm taking BSA, that is bovine serum albumin, and the varying concentration is 20, 40 and 60, that is 1:2, 1:4 and 1:6. And method and result, I have to explain the method of preparation as well as evaluation of microsphere. Method of preparation means I'm using emulsification solvent evaporation method. So we need aqueous phase as well as oil phase. So aqueous phase comprising various concentration of solution of BSA, that is bovine serum albumin, and as well as drug, that is our flurbiprofen. And coming to the oil phase, you can see that 100 ml of sunflower oil, 10 ml of petroleum ether, and an emulsifying agent, that is tween 80. So this is the method. You can see that aqueous phase, drop by drop, I'm adding to 100 ml of sunflower oil, which is preheated to 60 degree. And after that, I'm going for stirring at 600 RPM for 30 minutes on a magnetic stirrer, and primary emulsion is formed. And you can see the formation and solidification of microsphere. I'm going for decanting the microsphere suspension, getting and taking time for settling. Settle microsphere I washed with petroleum ether 3 times for removing the oil contents over the microsphere, and go for vacuum drying on desiccator overnight in a dark. And I got a Flurbiprofen microsphere, and I have made 3 batches with varying concentration of bovine serum albumin. And coming to the evaluation of microsphere, first I will go with drug polymer interaction studies using FTIR spectroscopy, and I have provided 2 graphs. You can see the 2 spectrum, IR spectrum of Flurbiprofen and IR spectrum of the microsphere, that is the physical mixture of drug and albumin, and we can see the similarity in the characteristic peaks in 2 spectrum, showing that there is compatible, or there is no issues with the drug and polymer. And coming to the surface morphology or scanning electron microscopy, I have provided 3 images of SEM, that is 20%, 40%, and 60% of BSA drug combination. And you can see that in 20% BSA plus drug, the surface is wrinkled and rough, whereas 40% and 60%, you can see that the surface is smooth and spherical. So we can see that as the increase in the concentration of polymer, the surface is smooth and spherical, and it is compatible. And coming to the frequency distribution analysis, frequency distribution analysis was carried out for all formulation, and all the formulation showing normal distribution curve, that is the bell-shaped curve. And drug loading and incorporation efficiency microsphere, we can see that the average diameter of microsphere is starting from 27.5 to 203 micrometer, whereas the drug entrapment efficiency of microsphere ranging from 48, that is FP1, to 79, that is FP3. And we can see that as the concentration of polymer increases, the drug entrapment efficiency of microsphere is increasing. And coming to in vitro release studies for Flurbiprofen, here you can see the graph having x-axis time and y-axis, that is percentage cumulative drug release, and the green is showing the FP3, which having high drug polymer ratio, and blue is showing low drug polymer ratio. And we can see that the complete release of drug from the microsphere is in blue one, that is FP1 has been done in only 10 hours, whereas the complete release of drug, the diffusion of drug, has been done over 12 hours for green, that is the microsphere having more drug polymer ratio. So we have conducted various in vitro release kinetic study to know the mechanism of drug release, and from the tabular column it is clearly understandable that all the formulation is undergoing zero order kinetics, and from the Higuchi metrics or Higuchi kinetics, it was found that the drug release is happened through diffusion mechanism. And in order to find out which kind of diffusion is happening here, we have to go for Pepper's plot or Pepper's equation, and from the n value of the slope, it is evident that it is a non-Fickian diffusion. And coming to the so these are the graphs which is we got from in vitro release kinetic study. And coming for the differential scanning calorimetry and DSC studies was carried out, and DSC of drug alone showed a sharp peak. We can see that in the left side there is a sharp peak indicating the drug having crystalline state, whereas the DSC of microsphere showed in the right side it is having a disordered crystalline state because it don't show a sharp peak. So this indicating a good compatibility. And coming to the conclusion, from the result of characterization and drug release studies, it was indicated that albumin enhances the solubility of Flurbiprofen from microsphere, and hence presenting a suitable method for preparing the sustained release albumin microsphere for poorly water soluble Flurbiprofen. So this is all about my research work. Thank you.